Thanks a lot. I'm Jeff Garzik, the co-founder and CEO of Bloq, and I'd like to take us through a little bit of an introduction to blockchain, a little blockchain 101. So I was honored to follow on to Mr. K from Humana, and he really gave, I thought, an excellent setup, not just blockchain 101, but blockchains, they're more than just a technology. We like to say that blockchain is really a process because blockchain is, number one, a technology. Number two, it's a process of examining business flows, business processes, where your counterparties and intermediaries are, where are the trust points in your current workflows, and how to make those more efficient, how to empower and really move to the next level. So without further ado, what are blockchains and how do they work? This is the slide that I would encourage everyone to take a picture of with your phone. This is really captures the key aspects or factors of blockchain, and we're going to go through some of those. Most important in the upper left is trust shifting, and I'll get into that in a little bit. But really, at its core, blockchain, the reason why it's valuable, the reason why it's interesting, is that you trust counterparties and other persons in the system, other remote servers, less, and you trust the network more. And that enables new efficiencies, new workflows, and that's really why blockchain is so exciting today. Decentralization, automation, cryptography. Permissionless is another one I like to highlight in that this doesn't apply to all blockchains, but like the internet itself, some of the value is derived most specifically from having an open network. So let's get into it. At a first glance, I don't talk about the technology. Blockchains are networks. Like the internet itself, the value of a blockchain is derived from the participants on that network. Blockchains are distributed immutable databases in that these are databases where any change to this database is permissioned by digital signatures, cryptographic technology, such that you can't just go in and if you're a bad actor or a malfeasant, etc., you can't just change that ledger. You can't just change that database. You have to have full cryptographic proof and provide that to the blockchain network. They are technological infrastructure. Blockchains contain a historic record of every change, making this easily auditable. My firm, Bloq, has partnerships with Deloitte and several other large audit firms that we're going to be announcing later. And the audit firms, these big firms, they look at blockchain and they see something that is not a T plus 30 days, and then you audit, or end of quarter audit. Blockchains enable near real-time auditing so that you have full visibility into every single change in that system. Blockchains are resilient, they're anti-fragile. They have network power that's based in cryptographic integrity. And this distributed computing power provides what's called a proof of work so that the data in the transactions, a transaction is a change to that distributed ledger, that blockchain, is fully verified by every single network participant. And so it's not just, again, one server, and that's where the power of decentralization comes from. Every single member of that blockchain network, every little dot, every little node on that network is checking the rules, checking to make sure that your blockchain database is valid. Now, you might have heard the term permission blockchains, private blockchains. I like to draw the analogy with the internet itself. There are some public blockchains. The most popular are Ethereum and Bitcoin. Bitcoin was the first, and I helped build some of the software related to Bitcoin. And those are much like the internet itself. Anyone can access it, and therein lies the power, but also the risk. The people who use public networks, just like the internet itself, there are banks on the internet, there are large financial institutions, healthcare institutions, etc., and there are also bad actors. There's also the dark web. There's also pornography, etc. And so there's good and bad on a public network. And for a risk-adjusted approach, particularly with financial institutions, insurers, they're looking at permission chains. And what is, again, the chain is a little bit of a misnomer. We're talking about networks. So this is a syndicated network. That's what a permission chain is. That only, say, the top 20 payers or the top 20 financial institutions might be on a particular network. And they agree to exchange data, share the rules, etc. And then a private chain, that's more like an intranet. That's a fully internal blockchain. And these are, we like to call these sort of blockchains with training wheels, because a private chain enables an organization to gain knowledge, gain experience with blockchain, but is a network of one really valuable? Not as valuable. So this is the progression that most organizations, enterprise organizations, take, is you experiment with private chains, you build permission chains within your industry, and often this involves your competitors. And so it's a very interesting situation of building networks where sometimes you have to involve regulators and compliance to get everyone on a level playing field. So what problems do blockchains solve? How do they solve them? One problem that they solve is something called the digital uncertainty or double spend problem. In the currency space, and this is one of the problems, one of the key problems that Bitcoin solved originally. If I have a digital $20 bill on my phone, and I take that digital file and I copy it to my co-founder's phone, how did I not just counterfeit $20? The blockchain network is what validates that one and only one of those copies is valid. It prevents the double spend, and that forms the foundation of the cryptographic integrity of these databases. It ensures that one and only one copy of an asset is existent on this network. And so far beyond digital currency, that's why many people are looking at blockchains for digital assets, asset tracking, time stamping, and provenance. Provenance obviously applies very well to the pharmaceutical industry, and ensuring that, for example, the active ingredients that are farmed, manufactured, etc., they're fully provenant through the wholesaler, the pharmacist, finally to the retail consumer. And immutability. Immutability is another very important aspect of blockchain. I like to use the example of down in Honduras. There are some experiments with blockchain, and they are trying to solve a very specific problem. And this problem is that if you slide some dollar bills under the table to a Honduran politician, they will go and change the entry of a property database, and now Jeff Garzik owns that skyscraper in downtown rather than the previous owner. So very corrupt system, and what blockchain and immutability enable is that you have that full audit trail, you have that provable set of ownership such that you cannot bribe a network, you cannot bribe the computer. They're very, very resilient. But even more than that, and this is what Mark Andreessen highlighted in a 2013 New York Times article, is trust. Trust is normally in a counterparty, in a clearinghouse, in a settlement system. And what blockchain offers is the potential to disintermediate those counterparties, those intermediaries, such that you shift trust from humans, potentially corruptible, bribable, or simply mistaken, to a network. And so trust is shifted to the blockchain network. So there's no need to trust the owner of a remote computer because you're trusting the network as a whole, which validates every single change to that blockchain. What are some of the opportunities that arise from blockchain technology? So blockchains are today in 2016, which is, as Chris, the previous speaker, hinted at, 2016 is really the year of the pilot, the proof of concept. We're experimenting, and so blockchains are a greenfield innovation platform. Blockchains allow notarized copies of digital files, so you can know for certain that some piece of data, some data file, some pharmaceutical transaction, some health record existed in a certain state at a certain time, and no one can go back like we saw with the Veterans Administration, VA, and change the waiting list ex post facto to say, no, we really had only 1,000 people asking for VA appointments, when in reality there were 3,000 veterans looking for appointments. So there is very real in the United States issues in healthcare that blockchains can solve. Another useful aspect of blockchain is something called smart contracts. These are sets of rules which are encoded in such a way that computers can understand each clause of the contract and can evaluate the performance of the party or parties involved in that contract. The blockchain network itself validates those rules. So again, you don't have to ask a human, a lawyer, to say, okay, let's go and check each clause of this contract. The computers can, in real time, audit and verify that this contract has been satisfied or not, that this value transfer needs to occur or not, that this asset ownership needs to change or not, that this property title needs to change or not. Very specifically in the healthcare sector, there are many aspects of blockchain that apply, and I think that this just really scratches the surface. Many people are looking at EHR, EMR right now. There are several efforts. Interoperability is quite rightly the word of the industry today, and blockchain can only encourage that. Again, blockchain is all about cross-validation, where every node is validating every other node's work, and therefore this allows a much more consumer-centric, patient-centric, end-user-centric, you're in control of your own data model from the get-go. Paradox, privacy versus transparency. I like to describe blockchains as security by transparency. Most of you have heard of encryption. Encryption is where you hide your data, you scramble your data such that only the person with the password, the key, can read that data. In contrast, blockchain is security by transparency. You have many computer nodes throughout the world that are continually cross-checking. Did this transaction follow all the rules? Did this transaction follow all the rules? Did this transaction follow all the rules? And so that's a very powerful system. It's much like the U.S. congressional or the three branches of government system. Each one of those, the houses of Congress, the judiciary, the executive branch, they're cross-checking and counterbalancing each other. Similarly, that's how blockchain functions, but transparency obviously runs right up into, right smack into HIPAA and patient privacy. So this is where blockchain and other cryptography can come together to make a much more powerful solution. So for example, I like to use the idea of you have an encrypted health record that is available to anyone with a key, and that works great if I'm conscious and I'm able to consent to, say, a doctor, a provider accessing my healthcare record, a insurer, a payer accessing my healthcare record. But what if I'm incapacitated? I'm in the back of an ambulance and the EMTs are treating me. In that case, what you see is with blockchain, as with many other sectors, sometimes you need a fiduciary, a third party, who can authorize on your behalf, based on records, rules that you have prescribed, that yes, in the event that Jeff is incapacitated, this person can unlock that healthcare record as well, this organization. And that organization would be not an insurer, not a provider, not a system, but a separate entity with the fiduciary duty in their bylaws to perform those specific actions. Claims processing, obviously there are months in many claims. Sometimes you have a situation where you're waiting on Susie the admin to update a taxonomy code for a specific procedure, and it's not even on the provider side or the system side, but it's buried deep in admin and coding. And this stretches out claims processing. Blockchain, again, with its digital signatures, digital identity, cryptographic integrity, can speed that process dramatically. Blockchains offer secure multi-party write access to a single database. And how it does that, again, is with digital signatures, digital identity. Every single change is, number one, signed off and authorized, and number two, tracked in an audit log. That's literally what the blockchain is, a chain of blocks. Each block is a computer data structure that includes changes to this database. And so it is literally, blockchain is quite literally an audit log of changes to a database. Multi-party, multi-step payouts. This is, again, in claims processing. There are many people who pay in, many people who bill, and this was one of the original use cases of blockchain itself, was processing payments, potentially multi-party payments, potentially with very specific rules prescribing when that payment can be released, when that payment can be approved. Interoperability, we've already covered that. This is the watchword not just of the blockchain industry, but obviously the healthcare industry as well. We very much believe in open data formats, open data structures such that anyone can access their data. That's very much in the self-sovereign, patient-centric view of data. Provider credentialing and enrollment. This is another pain point. Consider when a provider moves from a state to state, you need to change DEA numbers, et cetera. You have to go into the NSI portal, all that rigmarole. All of that can be associated with digital identity. And when a provider or, say, a nurse practitioner moves from Tennessee to Colorado, those digital credentials will follow them. Colorado can then say, okay, this Nashville system digitally signed off that this provider has the skill set, et cetera. This licensing board signed off that this provider has the skill set. So we can import those credentials directly into the system, and we have full digital cryptographic integrity, full chain of trust, chain of provenance for that provider moving. And so that eliminates so many pain points today for the providers very specifically, and makes that much more portable. And again, audit trails. Audit trails are very inherent in blockchain itself. And so once you have most of this data in a blockchain database, in a blockchain network, you can start to unlock the power, the value inherent in getting everyone on these blockchain networks. So part of Bloq's mantra is we're very pragmatic. We very much acknowledge that we're on the upswing of the blockchain hype cycle right now, if you're familiar with the Gartner hype cycle. So there are places that blockchain does not apply. There are risks involved in blockchain as well. So we're very pragmatic about where this technology does apply, how it should be rolled out. We'd like to say, again, blockchain is a process. It's a process of learning. It's a process of integrating these cryptographic technologies into your organization. And so, most notably, cryptographic blockchain type systems, they don't necessarily fit a perfect regulatory shape as it exists today. When I was at the White House for the White House FinTech Summit, the Secretary of Commerce, Penny Pritzker, rightly observed that technology generally leads regulation. And that's ad infinitum. That will always be the case. And so you have to work with regulators to understand the new shapes of these networks, the new interactions that occur on those networks, to number one, ensure that your regulatory compliance is up to snuff. But number two, understand that regulators understand that the landscape is changing, the landscape is shifting. And we're, in the context of healthcare, enabling patient-centric care and taking things to the next level. So we're almost out of time, but I think we have time for one question if someone would like to kick up a question here. We have a question down here.
I'm curious about your thoughts about implementation of blockchain in places like Africa and India. I mean, it seems like with Aadhaar and some of the interesting things they're doing in India, that they're making a hell of a lot more progress than anybody else.
No, absolutely. That's an excellent example because developing nations, emerging markets have a much greater opportunity to perform what I call a technology leapfrog. They don't have to deal with legacy systems, which many of us in the U.S. and Fortune 100 enterprises have. We've either merged 5 businesses over 5 years. We have a lot of legacy silos. None of that exists in the developing market, and so that enables them to move much faster. The canonical example being landlines for telecommunication versus mobile phones. And Africa, the entire continent, just skipped the landline rollout. They went straight to mobile phone, and you don't have to have a literal line running to a remote village. All you need is a cell tower, and suddenly the people in that village are on a network. And obviously, since blockchains are networked, that has direct applicability to empowering these people. So we can deliver remote healthcare, remote finance. In the finance industry, we call the people without bank accounts the unbanked. There is great potential in the developing regions to enable them to have a quick step up, rise from poverty to the middle class in that country for healthcare standards, for financial standards, just quality of life in general. So it's very exciting, and I think this technology is very empowering, not just for developing nations, but, not just for developed nations, but for developing nations as well. And I'll close with a geography note along those lines. My firm, we deal mainly with Fortune 100 financial institutions, insurers, et cetera. And what we see is the U.S. is moving pretty fast on blockchain. Mainland China and Asia is moving even faster. And now the developing world is starting to integrate this technology, and they're moving even faster than that. So it's a very exciting world. There's a lot that's changing. And so I'll close with that. Thank you very much. If you want to meet with me later on, we have a private meeting room next door. Thank you for your time.
Thank you, Jeff. We asked him to give this talk not only because he's one of the smartest technical minds in this space, but because he understands these concepts so well that he can distill them down and make them approachable. Up next, we have a short coffee break with donuts served in the Innovation Hall, followed by our 10:30 panels, which is Payments and Revenue Cycle in this room. We have Blockchain for Business in the balcony lobby, and we have our Technical Factors panel in the Mike Curb room over here. We'll see you guys at 10:30.